In this video, we're going to work on the ALEKS problem called Basic Properties of Logarithms. This problem is going to have three different equations in it. Each equation is going to be missing something, missing a term that we have to fill in. And to solve these problems, we're going to be using the basic properties of logs. So the first basic property of logs that I'm going to write up for you is if you have the log of one number, I'm just going to say A, plus the log of another number, I'm going to say B, that is equal to the log of A times B. And you'll be able to use that property to help you solve the first problem, problem within this problem. We have log of 7 plus the log of 3 plus the log of 7, which is equal to the log of 3 times 7, which is, we're just going to simplify that, the log of 21. For the second problem, the property that we're going to use is if you have the log of A and you subtract from that the log of B, that is equal to the log of A divided by B. And make sure you get these in the right order. So the first number is going to be the numerator in this fraction, and the thing that you're subtracting, that's going to be the denominator. So we'll use that to help us solve this term over here, just sort of filling in that format. If we have the log of A minus the log of B, that is equal to the log of A over B. In this case, 5 is our A and 9 is our B, and A is the number that's missing, which is 5. I'm going to go ahead and get this out of the way. Now the last one is a little bit trickier. This last one uses a property that says if we have the log of A raised to the B, an exponent, that is going to be equal to B times the log of A. And that's what we need to use to solve this last one. So we have the log of 1/9, and that is equal to -2 times the log of, we don't know what it is, I'm just going to say x. And the property that we're using, which I'm going to write directly underneath it, is the log of A to the B is equal to B times the log of A. Now from this relationship, we can see that the value of B for this equation here, the value of B is -2. We know that. So we know that we can just kind of squeeze this in. The value of B is -2. We know that the value of B is -2. We also know from this equation here, or from this right here, we know that A to the -2 is equal to 1/9. So we have to come up with a value of A that when we raise it to the -2, it gives us 1/9. And you might do a little bit of like guessing and checking, and you'll find that the value of A is equal to 3. So if we have 3 raised to the -2, that gives us a value of 1/9. If that's kind of stressful to you, like how did I come to that? Where did that come from in my head? Well, remember one of the properties that we have with these exponents, we know if it is a negative exponent, we can rewrite it in the denominator with a positive exponent. So A to the -2 is the same as 1 over A to the 2, which we know is equal to 1/9, and from this maybe makes it a little easier to visualize. A squared equals 9. If we take the square root of both sides, the square root of 9 is 3. So we know that the value for this problem right here, we just figured out that the value of A is 3. And that's what goes in this spot.